Oh, hi. We've been talking about the mole, working a few problems, and here's one which is not for an atom, but it has a formula to it. The compound here is called copper sulfate, and I have a sample here in this jar. It's a beautiful blue color. We call it copper blue, copper sulfate. The copper sulfate has 1 copper, 1 sulfur, and 4 oxygen atoms. And this is not exactly indicative of how the structure looks, but I did want to put together a model showing us the different pieces. So this might be thought of as being copper, 4 oxygens here in red, and then a sulfur at the center of these oxygens. So we've got ourselves 6 different atoms, 4 oxygens, a sulfur, and a copper. And the problem up on the board is asking us that the student wants to weigh out 1 mole of copper sulfate. How many grams should she go ahead and pour out of the bottle, perhaps onto a little piece of weighing paper in a balance? So we need to determine what's known as the molar mass. Molar mass. Molar meaning 1 mole, and the mass, how many grams per mole. Now previously, we took a look at the periodic table of the elements, and it has essentially molar masses, which we call atomic masses, meaning how many grams does an atom weigh? And in fact, more particularly, how many grams, 12.011 grams, does 1 mole of carbon atoms weigh? Well, this is not 1 single atom, 6 different atoms. So we need to put together the individual pieces. Let me draw up here on a board that we have 1 copper, 4 oxygens arranged in some fashion, and a sulfur. So we have 6 different atoms here. We'll find out next chapter that this isn't exactly how it's put together. We'll take a look later, but for right now it works just fine for us. Now, the atomic mass, or what's copper's contribution to this, is found on the periodic table of the elements. And I know copper to be approximately 63.5. 63.546 grams per mole. I'm going to put a little arrow here and go ahead and write down 63.546 grams per mole. We have 1 sulfur, and the sulfur is just above 32 grams per mole. And we have ourselves 4 oxygen atoms. Each oxygen is 16 grams per mole. I'm going to point an arrow to one of the oxygens and write down 4 times 16 grams per mole. So we essentially have pieced together the molar mass of copper sulfate. We go ahead and add these up. We have 1 times 63.546 grams per mole copper. We have 1 times 32.06 grams per mole for the sulfur, and we have 4 times 16 grams per mole for not 1 oxygen, but 4 oxygen atoms. We'll add these up together on the calculator. And we come up with 159.6. 159 point, let's go with 61 grams per mole, so that we go out to the hundredths place and maintain the correct number of significant figures. So the answer to this question, student wants to obtain 1 mole of copper sulfate. How many grams should she weigh out? She should weigh out 159.61 grams, because this is the molar mass telling us 159.61 grams is 1 mole of material. Let's do a follow-up question to this. A student obtains 100.0 grams of copper sulfate. Part 1. How many moles are present? How many moles of copper sulfate are present? We'll do another couple of follow-up questions in a moment. The student does not have a mole of copper sulfate. 1 mole would be near 160 grams. The student only has 100 grams, so the student clearly has less than 1 mole. start with what we weighed out, 100 grams of copper sulfate. We need a conversion factor. We're asked how many moles are present. Conversion factor, how many moles of copper sulfate are present? Our conversion factor is our molar mass. A few moments ago, calculated 159.61 grams per mole. Well, I need grams on the bottom, moles to appear, so I'll put moles on top. 159.61 grams of material is 1 mole. Do the division here. And I calculate this to be 0.6265 moles of copper sulfate to 4 significant figures. We started with 100 grams. Oh, a moment ago we just calculated how many moles of copper sulfate are in the 100 gram sample. Let's take this a step further and ask something like this. How many copper sulfate units are present in the 100 gram sample? So the student has obtained 100 grams of copper sulfate, and we're going to ask how many of these units are present. Well, in the previous problem, we just calculated that there are 0.6265 moles of copper sulfate present. We need a conversion factor to go to copper sulfate units that are present inside the sample. Well, on the bottom we need moles, and on the top we need copper sulfate units. So we're counting. It's the same thing as asking, hey, I've got so many eggs. How many dozen eggs? How many individual eggs? Well, the student has a 100 gram sample of copper sulfate. We calculated 0.6265 moles of copper sulfate, and now we're counting, saying 1 mole is 6.022 times 10 to the 23rd copper sulfate units. So on the calculator, 0.6265 times what's commonly called Avogadro's number. And I calculate 3.773 times 10 to the positive 23rd, which is an astronomically large number. We have many, many, many of these copper sulfate units present. 100 gram sample is approximately 1/3 of this jar. So right there we've got that many copper sulfate units. Let's follow this up one more time. Question number 3 for the 100 gram sample of copper sulfate is going to ask how many oxygen atoms are present in our 100 gram sample. How many oxygen atoms are present in the 100 gram sample? Every one of these units has 1 copper, 1 sulfur, but how many oxygens? 4 oxygens. So we have 3.773 times 10 to the 23rd of these copper sulfate units. We have 4 oxygen atoms in every 1 copper sulfate unit. Let me hold this model up just one more time, drive home this concept. If you had 2 of these units, one here and one next to it, you would say you've got 4 oxygens times 2 for a total of 8. Well, we've got 4 oxygens per unit, and we have a whole lot of units. So on our calculators, 3.773 times 10 to the 23rd times 4 oxygen atoms. And I calculate 1.509 times 10 to the 24th oxygen atoms. That's it.